I'd now like to go ahead and kick off our first panel discussion of the day by introducing our moderator. This first panel will be our Aerospace Integration panel and will be moderated by Dr. Matthew McCrink. Dr. McCrink is a research scientist at The Ohio State University, whose research interests include unmanned flight vehicle design and testing. Throughout the course of his work, Dr. McCrink has designed, built, and tested 1 full-scale aircraft and 45 unique unmanned aerial vehicles. He recently set the official world speed and distance record for an autonomous unmanned aircraft in 2018 using a turbojet-powered UAS with custom avionics designed, fabricated, and flight tested here at The Ohio State University. He is currently serving as the program lead for the Ohio State Assure FAA Center of Excellence, focused on the integration of UAS into the national airspace. He also acts as the PI for the development of an unmanned traffic management system for the state of Ohio. Please join me in welcoming our moderator and Aerospace Integration panel to the stage.
Our panelists join us up here. All right, well, welcome everyone. It's great to be here. I see a lot of familiar faces in the audience. It's wonderful to be in person here with you all, and look forward to our discussion today on aerospace integration. And so I wanted to kick things off this morning by just building on, I think, what Colonel Dice really pointed out is one of the key enabling technologies and key things that we're looking to do here as the state of Ohio, and I think one of the major hurdles that we face is the regulatory framework that allow us to essentially operate any number of uncrewed vehicles in the national airspace system. That is, has historically been one of the major challenges, but I think also major opportunities. And I think that the state of Ohio, we've been leading the way in enabling and developing some of the techniques to be able to do this. So we've seen a lot of great technical advances in development of UAS and UAM spaces. However, there's still that lingering, what do we do from the ground up to that 400-foot level that essentially will enable us to go out and actually routinely essentially engage with the national airspace system. And so the purpose of this panel is to pontificate on what the future airspace might look like and how we can close the existing gaps in surveillance and coverage to support not only uncrewed operations through the use of drones, but also as we look forward and extend these visions to urban air mobility and advanced air mobility concepts. So I think I probably shared this with a lot of you. I remember standing here or standing in these crowds about 5 years ago and thinking it was only 1 year until I could get my shoes delivered via drones, and that still hasn't happened quite yet. Right? We're not quite there, right? But I think we've sort of turned the corner from that what they call the the death valley of technological developments. And I think what has largely led to that has been the publication of additional rules put forth by the FAA, which have essentially paved the way, and it really sort of demonstrated what opening up low altitude airspace might look like. The key to that vision is really the establishment of public-private partnerships and involvement of local governments in establishing management services for that airspace, which allow us to do strategic and tactical deconfliction of UAS or other uncrewed operations in that airspace. And they really laid out, I think, some key milestones that will help us get to that point. However, there are still some key technical challenges that we need to work through as an industry here and as academia to understand essentially how these these air vehicles might transition from this airspace, this low altitude airspace, in which separation services provided by the FAA are not really being leveraged or used into the national airspace system. And so when we think about drones operating at low altitude, so below 400 feet, we're thinking about services that are provided by, again, these public-private partnerships, right? But as we expand into the urban air mobility, advanced air mobility space, we need to start thinking about, again, how these vehicles are going to transition between these low-altitude services and the high-altitude FAA services that exist now. And so, as there are test beds being set up across the country, I think Ohio is really leading the way through strategic investments that the Ohio Department of Transportation has made in establishing an unmanned traffic management corridor that exists here in Columbus, Ohio. This extends out along Route 33 and provides us this sort of pathway to test some of these techniques and for deconflicting this low altitude airspace. And so with that in mind, I want to focus this panel on really addressing the questions of what's next and what are the key technical barriers to really move forward and enable this transition, both operations at low altitude airspace, but transitions from that low altitude space into the national airspace system. And so I would like to introduce our panel members here, and I would like to start off with William Chen, who is the project manager for the ATM-X project, who previously conducted traffic management research at multiple branch chief positions at NASA Ames, where he supervised air traffic management research groups. Prior to joining NASA, he was a UASF flight test engineer for the C-17 program at Edwards Air Force Base, and a lecturer in metrology at the Department of San Jose University. Earned his Bachelor of Science in Aeronautical Engineering and Physics from Cal Poly, and an MS in metrology from San Jose State University with a focus on aviation turbulence. And so I'd like to offer William a chance 5 to 10 minutes on your vision of what the future looks like.
Great, thanks for the introduction, and it's great to be here at the Ohio State University. I'm thrilled to be among people who are passionate about aviation, leaders, experts, all working to advance air mobility in Ohio. So a little bit about the project. We're an airspace management project, air traffic management exploration. And we're looking at comprehensively how to build the future of airspace management for the vehicles that are already here, but also to integrate vehicles that are coming. And we've heard a lot about those already. The project has multiple focus areas, and one of them is Sky for All. This is to describe the vision of future airspace around the 2045 timeframe. And that work there will tell us what kind of research we need to conduct to get to that future state. And we work with the community here to define that. And we have a website here already established where we're inviting comments from the community. The other areas are the research areas towards that future vision of the airspace management. One of them is UAM, where eVTOLs, passenger cargo carrying vertiport, electrified aircraft. We're looking at that as a new way of looking at things differently. How can we develop airspace management technologies, leveraging what NASA has developed as UTM, unmanned traffic management system, and asking, does that framework extend to other areas like urban air mobility operations? And we're working with industry here, airspace management companies that have co-developed that system, similar to what we do with UTM. And we're looking at this collaborative federated system that works alongside the current FAA's ATC today. Another area that we're looking at is large aircraft, autonomous aircraft. We want to expand the use of regional cargo autonomous aircraft. We see it as a very strong use case, and I'm really happy to see this being worked here right at the Springfield Airport. We're looking to start here regionally in the regional airports, and then extend to more complex large airports to encourage the use, broader use of autonomous aircraft. Go a little higher up in the atmosphere, another area of the project, about 60,000 feet, upper class. We're looking at those types of aircraft, high altitude, long endurance aircraft for observation and surveillance. And again, we're looking not only how do they operate, what's the management paradigm up there, but how they transition from through the NAS to those high altitudes. For all the technologies that we build, we recognize that we need data. Data are the basis for the foundation basis for the algorithms that we develop here at NASA. So we are embarked here on an activity to make those data more available, more widely used to develop airspace management technologies, to broaden the use of it, to bring more people in to develop those technologies that work as a community. It's always found that working with the community, working with people that are experts in multiple areas, always improves our research, improves our end state technologies. We already have a lot of data. We've been working air traffic for about 3 decades. So we know how to work with the swim data. So with that data, we're going to continue to work with commercial airlines. And we'll be looking at efficient operations with American and Southwest. And so, but those data shouldn't just be well, the current operations, we're looking to expand those data for these new use cases. So there's a platform here we expect to grow. So in a nutshell, that's air traffic management exploration project. And thanks for having me.
Next, I'd like to introduce Lisa Peterson. Lisa Peterson is the VP of Business Development for Airspace Link. She and her team have been responsible for cultivating relationships with state and local government agencies as well as industry solution providers who rely on Airspace Link's Air Hub platform to ensure safe and compliant unmanned aerial system operations. She has significant experience in the areas of mobile communication, location-based services, transportation, and logistics technologies, and big data analytics. Throughout her career, she's been at the forefront of helping both public sector and enterprise organizations harness these new technologies to drive greater efficiencies, environmental sustainability, and economic opportunity. So, Lisa.
Thank you, Matthew. And it's a pleasure to be back here. I'm having a few flashbacks because the last time before we had the stop of travel due to the pandemic, I was here, not in this room, but at the OSU Aviation Conference on UAM, and that was February 2020. So it's great to be back here in person, finally. So if you are not familiar with Airspace Link, we are a sponsor of this event. We're very highly impressed with everything that Ohio is doing. We are your neighbors. We are headquartered in Detroit, Michigan, and there's probably some opportunities to be looking at some very interesting things that we could be doing together there. Our focus is to safely integrate UAS into the national airspace and into communities. So we are focused as a LANC provider on lower altitude small UAS services. But we refer to this as the digital safety infrastructure. We work with companies like Thales who provides the physical infrastructure, communication network systems, and surveillance systems. We're able to ingest that data into our platform, and we expose the data to all types of UAS operations, from recreational to Part 107 to now we're working with Part 135 type operators. And our main focus recently has been on beyond visual line of sight. We're working with communities the way our founding team has a wealth of knowledge in geospatial data science. So we're taking information that we get from our public sector agency partners, whether it be local, counties, state governments. We're ingesting the surface hazard data so we can mitigate ground risk for these UAS operations. That's really where we're specializing. We're looking at population movement patterns. We're looking at where people could be exposed and the probability of risk if there is an accident in this space. What is the probability of that risk? We are helping to inform beyond visual line of sight operational approvals with our data sets. So our goal is to make this a data-driven process to help the industry scale. And so you don't have to source your data sets when you are building your safety case and building your flight plan operations from 10 different places. We can expose all of those data services through our platform, kind of like you just said. And we are working with NASA on some other projects. We're an approved partner of the FAA for LANC services. And these are all key components of UAS traffic management. And we can elaborate on that a little bit more as we go along today.
Excellent. Thank you, Lisa. Next, I'd like to introduce Sean Calhoun. Sean Calhoun is Managing Director of Calpin Analytics. He has over 15 years of experience in the development of autonomous systems, focusing primarily on unmanned aircraft systems. Recent activities include research and development of Cal's unmanned traffic management, air mobility contingency management platform, and Ohio's UTM corridor system, in partnership with Ohio's SkyVision ground-based detect and avoid system, and is technical lead for several UAS-related research areas under NASA's UAS and the MASS program. He's active in the UAS standards development process and participating in ASTM and RTCA committees where it's the SC228 detect and avoid architecture and automation lead.
Thanks, Matt. And really excited, I'm sure, as all of us are, to be in the middle of developing this technology and these capabilities. It's a really exciting time to be in autonomous systems and in particular unmanned aircraft. And we really are building up a whole new air traffic management ecosystem, right, for the lower altitudes, so that these operations can integrate safely and robustly provide those services. Now, we are pulling a lot of lessons from the existing air traffic management system, but there's a lot of work going on in next gen to provide things like trajectory-based operations and traffic metering and things like that. But the existing ATM really still relies heavily on human-to-human communications, right? So very procedural based, a lot of interactions, like I said, between pilots and controllers. And, the challenge in developing the system for these unmanned aircraft is, we have to basically have a fully digital system. And that is one thing when things are going, smoothly and no disruptions or anomalies. It's another thing to how do you build in that digital flexibility to adapt to changing conditions and contingencies. And that's been our kind of tact, if you will, of developing, our technology platform is how do we build out the services and the capabilities to handle those all nominal conditions? How do we monitor that the system is up and running and everything is performing as expected? How do we handle, weather disruptions, sensor failures, disruptions to the airspace? And so, as we move forward, I think, we're still trying to, build out this puzzle, that is the lower altitude airspace system. And a lot of the pieces are being worked in standards organizations, and we still don't know what this picture is going to look like, right? But it's an exciting time to help, piece that together.
Excellent. Thank you, Sean. And finally, I'd like to introduce Steve Quiller. Thales has over 17 years of experience in the aviation industry, spanning a wide variety of technical and managerial roles in support of state and local government, airport, ANSP, civil aviation authority, military, and commercial clientele. At Thales, Mr. Willis served as a leading role within the Aerospace Mobility Solutions business, acting as a system of systems integrator, providing sensor technology with cloud-native digital tools to modernize and facilitate the integration of unmanned aircraft systems.
So good morning. Thank you, Matt. I'd like to echo everyone's appreciation to Ohio State and to the students who put this conference together. So at Thales, we have a rich legacy over 80 years of providing air traffic management capabilities, both on the software and digital side of the house. We like to say 2 out of 3 airplanes today take off, navigate to their destination and land thanks to Thales technology. And approximately 60% of the world's airspace is managed using Thales software. So when we start to talk about the evolution, or rather the revolution that's happening with the introduction of autonomous systems into the low altitude airspace, we really see this as a fundamental change in the way that air traffic management is going to occur as we progress into the future. And so with autonomous aircraft operating in the low altitude airspace, as Sean alluded to, this really provides a nice kind of segregated airspace, if you will, or sandbox for us to test out a lot of these new technologies that are really going to drive the future of aviation forward. And it allows us to apply the rigors that we've established from over 100 years of traditional aircraft or crewed aircraft operations, but it allows us to bring in some of these new capabilities, these new technologies, to really test them before we develop or deploy them more broadly to more of our traditional airspace construct. So again, Thales, we really focus as a system of systems integrator. A lot of the different elements or point solutions around UAS all need to be brought together into a comprehensive and cohesive system in order for us to really reach the full potential and to scale the small UAS operations within the low aircraft system. So looking forward to the discussion within the panel today. Thank you.
Thank you, everyone. And I think that's a really great overview of sort of the state of the industry at play. So there's really a vision that's been put forth, specifically by NASA and others, and building out an ecosystem to support that is really where this public-private partnership lies. And in there lies also the responsibilities of local governments to help flesh out and maintain some of these services as well. And so I think I'd like to start there. And the question is really in terms of who provides access and air navigation data to allow us to navigate these low altitude airspaces, whose responsibility is that? How do we do that? We have a really well codified system for how we essentially manage air traffic control data at a federal level for controlled airspaces. The means of providing providing the information to navigate safely across the wide variety of situations is I think, well established at this point. But for low altitude services, it's not as clear. And so maybe I'd like to ask you to perhaps pontificate on that for just a moment and kind of give your perspectives based on industry or you know, the NASA development perspective there.
All right, I'll go ahead and kick this one off. So, you know, the FAA has made it very clear that as far as services for a small UAS go, that there will be no services or investment in infrastructure for UAS that are operating outside of controlled airspace and below 400 feet. So if we look at a sectional chart of the United States, that's a huge geography. And really what it represents is a new opportunity that we're seeing states like Ohio and North Dakota, North Carolina, and others really start to take a leading role in terms of identifying what are the services, what is the infrastructure that's needed to support these scale operations and bring the benefit of this technology to our society. You know, and one of the challenges on that front, as William alluded to, is, you know, UTeam has a construct of a federated architecture, right? So a federated architecture, we're in a situation where we've got lots of different service providers. And traditionally, if we talk about, you know, crewed aviation, we've got one service provider within one geographic domain, or nation site. And so it's really an interesting time to see how we're going to have a community of service providers coupled with the opportunity that state and local governments now have to be active participants in the provision and management of services within the low altitude airspace.
Yeah, I would agree with that. I think that the challenge is going to be in, you know, how do we get uniformity, right? So there is no guiding specification or standard that's capturing all aspects of these services and operations. You know, I think that the key is going to be making sure that we have interoperability of those services, of those procedures between not just within the, you know, the United States and the 50, you know, if you just count the states, you know, the 50 potential approaches there, and then you go down to the municipality level, local airport level, right? And then interoperability with, you know, the globally, right? In terms of operating in other locations and countries there. So I think, you know, it's going to take a little bit to converge to a single set of uniform procedures and communication protocols and things like that. But I think that's going to be the key to enable states and municipalities, you know, globally, right, to basically stand up these systems at the local level, at the grassroots level, and basically have, you know, from an operator perspective, confidence that, you know, it's a single set of operating rules and data exchanges.
I agree with what both of you have said. I'll take it a little bit maybe from a different angle from the lens that we're looking through right now. We're finding that there are many new data sets needed in this industry that we have not come across before in the traditional manned aviation space. The eyes are removed from the aircraft, and they're very hyper-local events too that are happening here, right? So talking about setting up package delivery potentially in smaller communities like we've seen in Wing doing in Christiansburg, Virginia. So what does the lay of the land even look like? And that has not traditionally been an ANSP responsibility to understand everything about what goes on a community, even by time of day, day of week, where are population density patterns of people. And so because of the lower altitude uniqueness of all of this, that's causing the FAA to go back to the industry and say, okay, well tell me what data sets are important for building the safety cases so we can operate not only safely in the national airspace, but make sure that the communities and the people, the citizens, are safe in the community. So the lens we look through, obviously I already said, is ground risk. We have some expertise there where we're surfacing the ground hazards, but I think we're going to find just opportunity for new innovation here, and the FAA is looking for that.
So FAA always will have a role. It's the idea that we've been talking about within a project with the FAA the idea of delegated airspace with operational volumes. We think about the air taxi, leveraging what we've learned with UTM. You can have corridors around specific areas, vertical, those type of constructs. So the question that we are exploring and trying to answer is what happens when you delete those volumes? You always need optimal conditions and need to leave them. So the interaction between what we call ATC and this what we call the more collaborative federated framework has to be explored. And I like that framework there because it really does bring in the community. And I enjoy working with the community because we can help develop the system, and I see it as a way to accelerate the development and get vehicles into the airspace, working with industry and expertise and having them work alongside with us. So I think it's an interesting construct, but it does pose those challenges of how do we develop such a system that works seamlessly alongside, it integrates well. So it's a very smooth transition across those two different frameworks.
And I think that's interesting when I think about the infrastructure that we're developing and the techniques for managing low altitude airspace. There's a lot of different versions of this that are out there. Right? There's a lot of different data sets that are available. There are a lot of different procedures that have been developed to essentially specialize operations to the data sets that we have on hand. How do we see that evolving into something that approaches something like a standard? When I think about aircraft have gone through this development cycle where the first aircraft didn't all have stick and rudder and aileron controls, right? But eventually we sort of honed it and said this is probably the better way to do this, right? And we have some standardization, even though the roads are managed by state entities that are essentially all the same when you cross borders, except for maybe up north. So how do we see that evolving? How do we see those data sets being defined, and whose role is that to essentially establish what those standards might be?
I mean, I think it's going to be, to a certain extent, all hands on deck, right? So there are certainly some standards activities, a lot of standards activities going on as we speak, right? ASTM has a number of different activities, RTCA has a number of activities, and others. But I think to a certain extent, it's going to be just through, the classical crawl, walk, run, right? And figuring out what works best. I mean, we're still very much in the crawl stage of trying to get even repeatable, low scale, beyond visual line of sight operations. But I think and I think we're close to basically, and Ohio's been leading the charge on that, right? I think once we break through that barrier and can do that in a very repeated way, and the FAA becomes more confident in that, then we're going to start being able to, to your point, Matt, explore and really use that sandbox, right? To start, exploring how these systems are going to work in practice. I mean, we're doing a lot of rigor. NASA, the FAA is doing a lot of work in terms of trying to do workshops, modeling and simulation and analysis to figure out how this works. But until you get aircraft in the air doing actual operations, it's going to take some iteration there. Not this year in the States, but I think the key is making sure that there's information exchange across these sandboxes for lessons learned, and the best way to do this going forward.
I will say with the data services, I agree with Sean, we have to get the aircraft in the air. We have to get the operations happening and then start to learn from that, well, what data services actually did mitigate that risk and what data made it more safe. And then the FAA will be able to see all of this. Right now, I feel like they're taking a very conservative approach, rightly so, in all of this. But then as we start to move forward on this journey, I think we're going to see maybe, if our goal is not to have it take 2 or 3 years to have operations go beyond visual line of sight. So every time we go into a new state asking for beyond visual line of sight, the operator doesn't want to have to start all over again. So but that really is our goal. And I think we're going to make a lot of progress there. As far as the standard, I would look to ASTM. I'll share that we were invited by National League of Cities to participate in a ground to air risk workshop. And the cities are wanting to play a role too in all of this by exposing the right data sets. Again, from a safety perspective, everybody wins. So we're actually working on a playbook with them to help the communities become more informed about this space and how they participate.
Yeah, when I think about data sets, I think about the architecture for urban air mobility that we're developing here with industry. The idea of a supplemental data service provider, I'll just take it in that direction. Looking at weather as one of the elements that be coming out of those services is you want to get the best of industry, you want to get the best information, you get the newest technology to provide you that best information for your flight planning. But you'll have all these different components and how you get those standard, how you get them used for flight again, so that these are the right kinds of data and everyone's working for those some data sets. So yeah, it's a good question, and it's something that we have to work in with the FAA here, because you want to encourage broader participation, but then you also have this competition that I have this data, it's better than yours, I have this data, but it's something that definitely we have to answer. But I feel that's a good way to go, to just keep encouraging with the digital data, as I say, that to make it more available, is to bring that community, bring that technology into our airspace management area. Yes, it's definitely something we're definitely going to be answering.
I'll just add, I remember when the Aeronautical Information Exchange model first started coming out, or AIXN as it's affectionately known. And at the time I was working in the DoD world in the aviation space, and one of the engineers said, well, you know what's great about standards bodies is your people writing standards, they write the standards and then you got to cut their hands off so that you can like go and actually do something and they're not constantly rewriting the standards. But joking aside, I think that, you know, ultimately we're actually there. Like we have, the industry's gone and really created a leading position and created what I would offer some pretty robust frameworks and standards that exist today that will allow us to get the operations that everybody's alluding to in order to glean the lessons learned and to keep advancing and taking the next step forward. So I would offer, you know, if we get caught in you know, standards world, we're caught in kind of an analysis paralysis types of thing, and that really impedes our ability to put this technology into operation and to start to scale and realize the benefits.
So kind of building on that with the data services providers, on the federal level, there's sort of indicated that there's not much of a role to be played by the federal management of people allowed to do their space systems. So that brings into question or an opportunity, I think, for state entities to be something like an SDSP type services. And I wonder how you all are approaching that problem. How do you think about how do you engage the state entities to kind of navigate those data exchange services?
I'll take that. So we have interactive application that connects directly with the GIS platforms of cities, states, and regional county government systems. We do believe that the role to play is one from maybe a local advisory, right? Because things are happening in your state or in your community that are day to day that could provide risk to UAS operations. So by working with them, we're able to publish these local advisories, which are not temporary flight restrictions, but they are advisories, and communicate those out to the UAS operator industry through what we right now provide as our Lance application, which is, by the way, a free application. Anyone can go to our site and use the application. But the more we define, and I think we go back to how does everyone participate in this in the same way? And how do we define what a local advisory even is? Is it a certain airspace altitude? What metadata gets tied to it? We're starting to work through all of that. But we're at the starting point of at least enabling state and local governments to publish their advisories as an SDSP in the UCAN.
So I would offer that you have to look at the foundation of what services are needed. And really it all comes down into CNS, communications, navigation, and surveillance, right? And so if we don't have those services that are being provided through traditional methods that we have within the aviation ecosystem, I would offer that that's a great starting point for states or other entities to consider. And so we've seen and heard about a number of projects that Ohio is doing here within the state that support the establishment of CNS infrastructure that will allow drones to safely scale and operate advanced operations such as beyond visual line of sight. The state of North Dakota is taking a similar approach. They're actually deploying a statewide network of surveillance and communications infrastructure. But then importantly, we have to make sure that we're not just using the same old just because it's familiar to us, right? And so we're in this interesting transitory period where the FAA understands ground-based radar. They don't necessarily understand some of the newer technologies that are being applied today for airborne detection of weight, right? And so we're in a nice space here where we can start to take some established technologies that we're comfortable with, that are proven. We can start to use those to scale operations, and that will allow us to then start phasing in some of the new capabilities that various players are bringing to the table.
Yeah, I would say, as I mentioned when I kick things off from my perspective, we look at things as, how do we handle things when they're not going as they're supposed to, right? And we have these disruptions. And I think there's still a lot to figure out, and a lot of diversity going on there in terms of what role the local entity is providing for those type of services, right? So the original concept was a very federated, unmanaged system. But to see that actually become a reality, a whole host of automated systems are going to be required, which aren't quite there yet. So I think in the near term, you're going to see some demand for providing some type of supervisory role. How do you gain access when two people want access to the same airspace? What do you do when there's medvac requests and things like that? So I think it's going to be key to figure out what is that role, right? Basically the roles and responsibilities, and whether it's a state, municipality, or whatever, defining what that supervisory role is in the near term, and then eventually you can transition that to a more highly automated system. But I think it's going to have to start with some more procedure-based involvement.
When I think about, say, urban air mobility, I think of regional air mobility, the ability to tripling, you go from a car to eVTOL, go to the airport, those types of things. I look towards something that's fully integrated, the ability to go see, that's the idea of on-demand, right? The idea that you want to save time. So having information about the ground state, vehicle state, we work with the cities here in regional air mobility, is to make sure that we're not creating hotspots when we do vertical sightings. And what is the impact here of if you do these vertical sightings on traffic? If we created an issue that really wasn't there before. So and part of using a wide range of data, it'd be great to get those kinds of data about traffic usage, traffic patterns, and work with cities to address that. I also think that besides data, this information, working with local and state governments about use cases. I'm looking forward to these use cases that impact to the community, looking at use cases that are, say, like medical or infrastructure, and let's see how our technologies can enable that. And I think the state government can really bring people together. Like I see here is OEMs, airspace management providers, data services, surveillance, and really provide us a place where we can really test our technologies out in the field. So I really feel like there's a wide range of information, capabilities, opportunities, and data that we see there.
Excellent. So I think we're all in agreement here about sort of the opportunities I think that exist out there for development and inclusion of these systems. But what are some of the key technical barriers that are standing in our way at the moment? And I think specifically speaking as an academic, what are some of the key research questions that we as we think about expanding the systems or availability of data streams or looking at interoperability? What are some of those key things looking at?
Oh, we fill it with security, right? I mean, you really got to have data that is secure, especially if you're going to have a digitally enabled network that's communicating with aircraft, digitally autonomous aircraft. That's got to be secure. And so we were looking into that. We've looked at advanced ideas here. We hear about blockchain technologies, right? And so, for cryptocurrency, I had a server running in my garage, and so I learned a little bit about that. Sometimes you just got to be careful. electricity costs them outweigh what you're doing, but it became a nice little heater in the winter. I mean, these are the kind of things that really, when we talk about it, you just can't overlook. And that's something that we have to look at the people that have done this. And this is being in Silicon Valley, what are you known for? You're known for high-tech companies that know how to manage, how to push data, how to secure data. So we look outside what I call the gate and kind of bring that community with us and look and provide them sort of a benefit. Why would you be in this space? Why would you be here? And we just look at all the different use cases of energy around advanced air mobility. And we hope to bring them in there and show them that, wow, look at all this. And you could actually come here. It would be great to have Microsoft be part of this, And it's not to say that we haven't talked to them, and we will, and yet we are. So, and the Googles of the world. Who would ever think Google would actually be part of like aviation, right? They're funded out of Larry Page's, right? As PK, let's say, out of his back pocket is a checkbook, right? But yeah, as an IT company, I think it's really exciting. But yeah, we actually be looking at security.
I would also offer, and you can talk about the DA, I'll talk about big data. I mean, this becomes a big data, very complex issue as we talk about millions eventually of small UAS and then integrating the larger aircraft into the system. This is really a big data issue, and having those technologies as part of this equation is going to be essential, right? All of the cloud-based services, how do you handle millions and millions of transactions that's happening and tracking where these aircraft are. So that's, I'm not going to say that we're more medium data in terms of what we deal with right now, but there's the big data complex issue in this industry for me.
I would say from my perspective, interoperability is a big one, right? That eventually we're going to have to solve not just interoperability between the players in the low altitude airspace, but interoperability with the air traffic, the existing air traffic management system. So, people file flight plans that are going to transit. How do those propagate through those systems in a seamless way? I think the other big piece to this, and this is something I know that the Air Force and others are heavily invested in, is trust and autonomy, right? So how do we build up the testing mechanisms, the design assurance, and systems engineering aspects to make sure that these highly autonomous, highly automated systems that we're going to be putting in the sky and using to control the airspace, right, can be trusted and have the robustness to respond to all phenomenal conditions.
So break out the bingo cards, because here comes a lot of buzzwords, right? But William and everybody really touched on it. When you talk about IoT, big data, machine learning, AI, right? All of these concepts that have been deployed or developed or constructed in other industries, so to speak, that haven't been applied to aviation yet. I think really that's the opportunity, if you will, from an R&D and research standpoint, to really understand what is the applicability of these technologies in aviation. Does it actually bring benefit, right? And then obviously in a truly connected environment, digital environment like we're talking about here, creating here, how do we secure that across the entire data chain? Anybody get a bingo?
No, that's great. And as I think about this problem, I keep coming back to this idea, kind of what I said in my opening monologue. It's great, and there are these challenges that definitely exist. But how do we get off the ground? I still can't get my shoes delivered. Right? And the basic demonstrations have been conducted in ways that the caveats and the procedures that are developed aren't really scalable in any major routine operation sense. So I guess can you maybe talk a little bit about where you sort of see the next, what we hope will be the next year or two that gets us towards something like routine DV loss operations, what that might look like, and your thoughts on how we grow from where we are.
I'll kick us off here, and I'll kind of table the regulatory and policy discussion here to the side in my response. But what I'd really love to see is more operational services and understanding of how these services are going to allow commercial operations and advanced operations to scale. So if we think about Lance was deployed in 2018. And since then, we haven't had another single UTM service, if you will, that's been deployed and made available valuable to us. So we've got, the remote ID implementation that's on the horizon. I think that'll be great. It would be great to see that rule to be more encompassing and more robust, rather than as narrowly focused as it was. So I'd love to see more clarity at the federal level and deployment of operational services rather than just concepts of operations, but actually deployment of operational services. And then I think that's going to foster the growth and development of what states and localities, and to be large, the private industry, and what role and services we can play to help support the growth of everyone.
I think what I think would be very helpful to, accelerate, so that Matt can get his shoes in an hour, would be more open sharing of safety cases and information, right? So, some of that gets published, but I think a more community-based exchange of best practices here, the various services that we found successful with the FAA to get approval. I think that will drive uniformity in the response and quicken the response from the FAA, hopefully. And so I think that's going to really have to come, though, to be honest, from the grassroots perspective, right? And where states like Ohio and North Dakota, right, if they can get together and start that exchange of information and force industry to, be more forthcoming with that information, I think that would really help the, in general, lift all those.
Yes, there is progress. There are 14 companies going through type certification now, so there should be more clarity on how you actually get type certified from an airworthiness, durability, and reliability perspective. The Beyond Visual Line of Sight Aviation Rulemaking Committee was formed, and so they put out their recommendations, and then that will be used to inform an NPRM that comes out later in the year. So we're seeing some light at the end of the tunnel when it comes to what is that recipe for Beyond Visual Line of Sight. Ideally, this performance-based approach where the industry just says, tell me how you want me to perform and I'll do it and I'll bring my safety case. That's what's been missing. I think we have a lot of the ingredients, but the whole recipe's kind of been unknown, and that's what Sean is alluding to here. There are some things coming out that, like we just saw that Wing had an exemption and there was a list of limitations and constraints. That's publicly available information. Sometimes you have to dig for it.
Yeah.
But there is some light at the end of the tunnel forming. We're part of 3 FAA Beyond programs, so that's a continuation of what was the integration pilot program. So we are working with North Dakota and Choctaw Nation, some of the original participants on just moving this space forward so we can get to Beyond Visual Line of Sight.
Yeah, so definitely safety is key. Airspace management, safety, efficiency, they go hand in hand, right? So you got to be able to prove that safety case. And I think the systems that we talk about, they have to prove to be safe and reliable. We talked about that discussion about redundancy yesterday, and we talked about systems that just need to be, you be assured that they're always operating the way you want them to operate. I think there's another way to think about this is to look at how do we show this, and I like to just use the sort of the public good use cases, medical infrastructure, and start using that as a way to build safety, get the metrics, get that information to show that these operations can be safe, and in an operation that people can understand, like, oh yeah, this is beneficial, so that you can get some energy behind those kind of operations.
I want to key up something I think you just said there too is public perception of these operations. We really start to stand up, scale up, and it goes from an idea. I think in our heads we all had this vision that we were seeing drones flying all over the place by this point, and not quite there. But when that happens, right, we can expect some outpouring from the public. So how do you think about sort of engagement with the public at large, and how do you convey and describe some technologies about it?
Yeah, non-flying public. Yeah, this definitely is. Yeah, you got to listen to the communities. This is back to working with local agencies, cities, municipalities, and asking where what are the use cases that you're looking for, and what are the things that we need to address to make this a viable, advanced air mobility viable in your community. And so when I talk community, I talk in there's the classic people we work with, agencies work with for airspace management development. But we also have a group here of public, non-flying public, that we also have to listen to, and we've seen how they can be influential and how airspace management technologies can be deployed. So definitely work alongside, get their input, and this is part of the Sky for All, is that we're putting this out as a community, and tell us what you think about this future vision. We want to hear from everybody so we can get all the ideas and look at the comprehensive solution and address the major barriers. But yeah, public perception is important, and we talk about noise, right? There's noise, there's visual noise, and there's acoustic noise, there's frequency, and multiples all. So definitely have to address that. But yeah.
We've put out a program called Fly Safe, and we're launching that program around the country with cities and counties. And it does entail workshops. So we offer that we will do a workshop. We will help them engage with their key community stakeholders, whether it be businesses or people of the community or the hospitals. And it includes actually even standing up a website where they can communicate information to their community about the rules and regulations. A lot of times, even though as much as we are in every FAA industry forum and all trying to get the word out about how to fly safely, if you're a Part 107 or recreational flyer, or maybe you are going to get your Part 135, what are the rules and regulations? And if you go down to the local levels, a lot of times they don't know. So that's what we're trying to do, just amplify the FAA message with our Fly Safe program.
Yeah, I do think that it's going to be key to have that community outreach once these things really do start, taking to the sky for, real operations. I'm reminded of the story in New York where they started using the Boston Robotics dog to help aid some of the first responders there. And there was a huge public backlash, and the whole program got, canned. So, I think we need to be out ahead of those type of things, early and emphatic, right, about it, because the last thing this industry will want is, this technology to become politicized. So, not that happens in this industry.
Yeah. So I'd be remiss, I stand here as, again, kind of a reluctant optimist, where it seems sort of the promises in the industry are, and it's taking a little bit while to get going to the point that we can do these sort of routine commercial operations. But I do see that as the logical next step of where we're headed. And I think the next time we gather in a year, I think we'll be having a very different discussion here. I hope. Fingers crossed. So if we kind of build on that a little bit further, I'd be remiss if I didn't try to tie in some of the more advanced concepts, or urban air mobility, advanced air mobility concepts, where we get away from this idea of small packages moving small distances and start putting people on board. How do we see essentially the roles of, again, this public-private partnership that exists at low altitude airspace playing in that?
So to me, it's a very exciting opportunity that's in front of us. I think we all realize a lot of the challenges that stand before us. But what excites me about urban air mobility is, we stopped talking about UTM or Class E array. We stopped talking about segregated airspace, and we talk about integrated airspace. And really that's our focus, because a lot of what we're doing now in the low altitude airspace is going to transform the way that we manage airspace in the future. And so for me, that's really the hurdle and the exciting thing in front of us. And so we're starting to take some of what I'll call our legacy technologies, systems, processes, et cetera, and we're melding that with the new. So that will be the challenge, but also the exciting part. And I think you've seen kind of some potentially logical approaches to that, with regards of using corridors for segregated airspace and whatnot as kind of logical first steps to test and prove out the technology before we start to increase the geographic scope of its deployment.
Yeah, I've actually, been pretty impressed with the level of public-private engagement. If you look at a public airport to test out their technology and have interactions with not just the, it's a local interaction, it's at the state level and at the federal level, right? All three basically investing in the private industry investing and getting these technologies off the road. So I think there's a lot of desire and acknowledgement that these technologies could be, very, transformative in terms of our, transportation modalities. So I'm pretty encouraged so far what I've seen. I think we just need to, keep it up.
I agree. I think NASA doing the right thing to provide the programs to enable this. Same with the FAA, and we did see this in the small UAS space with UTM, and industry participated. And it was the industry. The job of that NASA and FAA is not to build your business. They have to build their own business in the end. So it does take this village, I guess, of the public and private industry partners coming together to make this work. And we're seeing some of that with definitely the automotive companies too, starting to fund this space.
Yeah, I obviously, I think it's been working really well for us at UTM. And it really started as an idea that NASA has, and you work with industry, and the initial architecture was changed as we worked with industry, and the piece came and we got the feedback. It actually affected how that architecture was developed. As you look at the end state from what the initial idea it was to where it ended up. And then we continue that for urban air mobility, and we're looking at that for other use cases within the ATM-X project portfolio. Yeah, I like to see this keep going. I think it's really good. I think it's beyond just the companies, but it is municipalities, the states. I like that partnership, so I think I see a lot of benefit to that.
I think last question before we open it up for questions from the audience here is one that I've been curious about, and I'd like to start with Steve here. We're not the only ones developing these types of systems, and there are various incarnations of UTM and AEM type supportive systems that exist outside the United States as well. And I'm curious about what lessons can we learn from some of these OCONUS activities and apply it to what we're doing here.
Yeah, I mean, there's obviously a lot of individual approaches, but I think collectively everybody's working towards the same goal across the globe. I think if we look at Europe particularly and what they're calling their use-based implementation, they've been very clear with regards to the planning and what services are going to roll out, what those timelines for rollout are, and then they've supported that from the regulatory and policy front. And so rather than just floating out concepts, I've seen that they've been a bit more decisive, it might be the right word, in terms of laying out an implementation, not only an implementation plan, but a regulatory construct to support the actual deployment of these technologies, both from a service construct as well as from an aircraft and infrastructure certification construct.
Yeah, I would agree with that. I think that, one of the things I've liked what I've seen with UseBased in the European is, to Steve's point, they've been very decisive in terms of laying out, here are the services that you need to do, and here are some basic rule sets for, operating in that airspace. Not prohibitively so, right, where it's dictating down to too much design level. I think they hit the right, sweet spot, if you will. Hopefully, maybe with the BPF, the ARC that just came out, right, the FAA can kind of take a similar paradigm and start defining and writing down at least some of the basic steps to that recipe of about what services and approaches needed to get approved.
Our approach, we have been following some of the international organizations, and some of them are using from a risk approach, Jarasura, that model, and that's not what the FAA uses, by the way. So it makes it a little complex if you are trying to serve the world right now, because there are differences. I would say at this point, we're following, we're monitoring, we're really not participating so much right now in the international UAM or UAS space, except through, we do some work with Thales, and we're looking at some countries to expand into. Our partner Esri is also very international partner. They're one of the leading GIS spatial firms. But right now, we have a lot going on in the US. We're starting to look at the cross-border opportunities between the Windsor Bridge and Detroit and going into Ontario, Canada. That's really all I can comment on.
So as a research organization, we work with international research groups, and oftentimes we find them looking at use cases that we've yet to really dive in as deep as they are. For example, you do disaster relief activities with a small UAS, but then they're also interacting with helicopters. So organizations that look at that, we're like, oh yeah, how would you do that? What is your concept there? What technology, what information, how does our technology enable that? Another way we look at is common problems that different countries, different areas of the world, they look at the same thing. So we share ideas as a research organization and as engineers that build the technology. It's really interesting to see the different perspectives, and you can go to different countries and you can talk about urban mobility, ask a similar question, get similar concerns, but how are you addressing it? And we'd like to get those best ideas and bring that back in-house for our researchers to see to integrate it into our work.
I'd like to turn it over. We have a few community questions here we'd like to address, and then we'll open it up to the floor at large for others. And actually, kind of building on this, I know NASA's currently going through the AAM national campaign. Yeah. And the question is, how will NASA's AAM national campaign inform the airspace development activities? And will it provide the info with enough time to do things?
So what I was describing about working with the multiple airspace management companies is we're working alongside and we're building with them. So NASA is building our system alongside with industry, because we learn better about what they're doing by doing it ourselves, kind of this learn by doing approach, which I really like. So part of the system there is up to deployment support for the national campaign. So there are multiple aircraft manufacturers, and they're partnered up with airspace management companies to perform the different scenarios in the national campaign 1 series. And so that's what we're doing there for the national campaign.
And there's a few questions here that I think actually kind of tie together and really looking at the safety risk benefits of developing some of these technologies. So there's some questions about the chicken and the egg problem of developing standards without being able to test them. Right? And how do we sort of think about that? Are there activities that we can do, or a role for NASA to play in really kind of helping pave the way, towards demonstration of the maybe loss activities or integration of UAM, AVM concepts?
Yeah, so I do look, to have the integration of those different types of vehicles. They are operating in the same airspace. And part of our work here is to develop technologies so you have that seamless integration awareness of those different operations. We can certainly do them in the lab, and we take them out to high fidelity simulations. But I think really what we'd like to do is go out in the field and get that real world demonstration to kind of inform standards bodies for this work. I think part of what I see here is, what kind of use cases make sense? Where can we do this kind of work? And seeing this great partnership here, it looks like a great place that people are really leaning in. So it's almost like just kind of finding that use case, working with the right people, and then building up the information that we can work with the FAA to help and other standard bodies. All those requirements to be working with other people in specific use cases.
I just very quickly offer that I think a great example of some of the collaboration of standards in industry and demonstrating the capability would really probably be around the concept of remote ID and the standards that were put out there, right? So we've had a lot of different approaches to remote ID. The community got together, they formed a standard around both network and broadcast, and now there's parts of the industry that are actually making commercial solutions available, and we're seeing remote ID or electronic security implementations that are occurring not only here in the United States, but elsewhere around the world, Switzerland and other locations as well.
So we have two questions here that I think speak directly to some of the ground risks that you all are looking at. And they're, how do we ensure safety is the risk of benefit? And the question is, there's a difference between conducting these operations in North Dakota, New York, and
I mean, I think that's what we're all striving to figure out here, that, going back to what that recipe is, because you have different types of use cases, different type of aircraft, different types of payloads, different weights, different speeds, and all of that has to be factored in when you're looking at ground risk. So that's why I say it's a ground to air modeling that we're doing to determine what level of risk. And we have some models that do some risk scoring, and in the end, it's not prescriptive, it's to inform a better plan. And the way we look at it is having some data is better than not having any data at all to inform your planning. In this space right now, it is the operator, the pilot in command, that has responsibility to make sure that all the operations are safe. I don't know if I'm dodging your question a little bit. I don't really have a full answer for it. But it has to be data driven. It has to be quantitative and data driven. I think this going out to Google Earth and finding 10 data sources and bringing it back to the FAA to see if it makes their safety case is not the right answer to scale the industry.
Yeah, the only thing I would add to that is I think having some more guidance from the FAA in terms of here's the rock you need to bring us, right, if you will, and telling us, like I said, here's the different things you're going to need to mitigate. Here's the level of service requirements that need to be developed for these certain types of risks. And again, I think a little bit more guidance on those fronts in terms of in the different operating areas. Here's the things that you need to mitigate. I think would be helpful. SOAR did that. It wasn't accepted, and again, that was for less complicated operations, granted, but if the existing ATO safety case is pretty, I would say unclear in terms of exactly how to adopt that for these different operations.
Right, so I think as we come to the close, I'll ask maybe just one more comment. What are we going to be talking about in a year here?
The BB loss and PRM.
Excellent. Excellent.
I hope you talk about what our project here has been doing with Ohio, state of Ohio out here and locally here in the area to push forward advanced air mobility. So I'd like to be back here and report on some good news.
All right.
I'd say one of the Ohio teams went the Super Bowl, but
Or BB loss.
Or BB loss.
Okay, well, I'd like to please give a one.
Thank you, Dr. McCrink, and all of your experience. I know speaking from the perspective of both manned and unmanned pilot, the airspace question is one that I often have to consider. So I found all of your insights, especially in